Excited to be here. And today I hope to speak a little bit about Will. And yeah, first start some introduction. My name is Bruno. I'm a senior staff engineer at Will Bank in Brazil. I love traveling because I travel like lots of hours from Brazil over here. So you need to love travel to do that. And yeah, so I want to speak a little bit about Will and what we're building with Temporal. But I think that before that, it's useful to tell a little bit about the company, the stage we're in, and what we have to offer and what we do. So Will is a digital bank, so kind of like a fintech, and well, we're a real bank, so we offer a wide array of banking services to all of our customers. So in our application, our mobile app, you can specify, for example, checking and savings account. You can invest money as well. Money transfers from peer-to-peer, payments, withdrawals, and more, and also offer credit line. And yeah, so we're basically a bank, right? So all the digital and engineering challenges that comes with banks usually appear here. But the fintech market in Brazil is pretty competitive, actually. We have a lot of competitors, and well, what is our differentiator? And the key thing about Will is that we're focusing on the underserved customers, and Brazil has a lot of these people who have never had a credit line before, don't have a credit card, don't even have bank accounts in some cases. And we have a lot of customers who Will's is the first bank, so the first ever bank experience. And it's important, and for me, it's kind of like a responsibility in order to offer like a good banking service to these customers who never had it before. And about some numbers, some financial indicators that I think is interesting. I'm gonna be through all of them, but we have 12.3 billion credit card TPV in 2022. You can get an estimate in US dollars if you divide this by 5. It was a rough estimate, but we also had a 70% year-over-year revenue growth in 2022. The other sign that we're growing is that when I did the title of the stock, we had 2 million customers. Now we have 5, so we've grown a lot since March. Yeah, it's quite a big number. Yeah. And yeah, so this is the company that I work in, and I joined back in March in the banking transfers team. And it was funny because the banking transfers team had a domain, but we didn't have any ownership of the projects that we inherited, right? So I joined the team, and my director told me, so this team handles banking transfers. Everything is related to banking transfers, but we don't actually know where the services are. So I'm going to find out where the services are and find out what they do. And I was like, okay, this is a bank, okay. And so the first step that I got there was like first learning a little bit about banking, and also learning what we had, what we offered, and what the problem was. So I want to speak about 2 use cases that today. One of them is the debit card and withdrawal transactions. And these are the 2 most interesting ones. Ones we're going to talk about how Temporal fits these use cases and how it helped us solve a lot of problems. The first one being the debit card and withdrawal transactions. Let's start with this one because it's the most familiar to the US audience. But usually, like, everyone has used the debit card at some point in life. And the key thing about this is low latency. So this is a transaction that needs to complete. We have amount of time to complete it around 4 seconds. And so it's not like low latency in some millisecond, but still pretty fast. For us at Will, it was a high source of contact rate, which means that customers were complaining about this feature a lot, and for good reason. We're going to talk about the issues later. It's also, for me personally, I feel like it's one of the main things a bank needs to offer. So if it doesn't work, then you kind of like wonder, how do you work as a bank if this like super simple, quote unquote, thing or feature doesn't work? Like, I should probably just choose another bank, right? So for me, it's highly critical that this works. And this is what we inherited. So when I joined, like, I had to like find out and build diagrams of what we had. And what's on the left here is the external world. We have a point of sale machine, or maybe the Will app doing some online debit card transaction or even a withdrawal inside an ATM. It all goes through a partner called Fast, which is the card processor. And eventually on the right, it reaches the internal service, which on the right, we're inside the Will's infrastructure in AWS. And then afterwards, we decide using the ledger, which is the account partner on the right, if we should authorize this transaction or not. And we do some push notification through an internal service in SNS, right? So we push to this topic, and there's some other service that consumes this and sends the push notification. And for this, we're looking at 160 requests per minute. So this is enough this is not like that huge, but it is enough so that if it fails, you're going to have a lot of people complaining. And this is also a source of cost, right? So we don't want that happening. There are some problems with this inherited services that we got. And I think the main one is there's nothing maintaining a transaction around these services. So we can and we do end up with an inconsistent state in a way that if the transaction fails and we fail to reverse the money back to the user's account, he's going to have less money in his account. He's going to be nervous, going to reach out to chat and complain. And I mean, that's what I would do. And also, we use this external ledger. This is also something that we inherited. We did not build the ledger, and we're currently in the process of building our own ledger. But this external ledger is really not good and not very flexible. One of the things that we wanted to do for this use case was, for example, to add a tax for withdrawals. And in order to do that, we would have to reach out to the external ledger and ask them to implement that. So we basically have no control and no ownership. The second use case I want to talk about, and this might not be familiar to the US audience, is Boletos. I really tried to translate this, but there's no translation. That's just the name of the thing. And you can think about this as a sort of delayed transaction. So as I mentioned at the beginning, lots of people in Brazil don't have a bank account or don't have a credit card. And what happens when these people want to buy something on Amazon? They use this, basically. And this is a sort of delayed transaction where you can pay this document. It's like a legally binding IOU. You can pay this in any bank, and eventually Amazon will receive the funds and move the purchase over and move on and deliver it to you, right? They're highly flexible in which that they can be paid in pretty much, they have a time, they have a due date, and they can be paid up until the due date, sometimes even after, depending on the rules. So they're pretty flexible. They're also highly asynchronous by nature. In terms of system design, you would get the payment of this as a bank eventually, like one day. And today, like it takes around 3 days for the system to identify that this has been paid, that we get like a sort of like a webhook from some other place. And this is an example, right? This usually you would get this as a PDF document, or you would get this as a in the app. You could download it or receive this by mail. Or we get our electric bills, for example, or internet bills in this format. There's a couple of interesting things here. The first one is the barcode. So this uniquely identifies the paper, and then you can pay this in any bank using the barcode. Our app has a barcode scanner you can use to scan this. This little number on the top is basically the barcode, but it has some extra fields to make sure that you're typing the correct thing. And on the right, you have, like, for example, the due date, the value, and some other information that the emitter decided to put there. So today, this is the architecture that, again, we inherited this. As I joined, this was in place already. And yeah, so the payment comes from our Will app in the phone, so the user can scan a barcode, reaches our BFF layer. It then forwards this to a service that does some validation and forwards this to another service. And eventually this service maintains the transaction state and saves it in a MongoDB database, and then reaches out again to the external ledger to complete this payment. And it's actually the external ledger that handles with the payment. And that's what tripped me up the first place. Like, okay, there's something else doing something that is highly critical. That's usually a red flag for me. We're looking at 150 requests per minute. So, again, if this fails, people will complain. I would say it's a little bit more critical because you're paying bills with this, or even like buying something on Amazon, for example. So people want this to happen, or at least know that it didn't happen as fast as humanly possible, right? So yeah, these are the these are the two use cases. And this one particularly, again, also uses the external ledger, so not flexible, even more so because the actual payment happens outside of our control. So we actually don't know if the payment happened or not. And that's, for me, that was crazy. I was like, okay, this is just cannot be this way. And it's also synchronous. So this means that the user is waiting on the app for the payment to happen. And our P99 for the service is 1 minute. So the user is just sitting there on the app, looking at the screen for 1 minute and waiting for it to complete. And we all know Will has grown from 2 million to 5 million customers. Once we reach 20, this is probably not going to work anymore. It's already not working as we expect. So if we want to scale past the 10 million mark or even the 5 million mark, that's something we probably had to fix, right? But first things first, I joined the team and we're at this point where we have no ownership, as in we don't know where the services are. Everything's scattered around as GitHub repos. Every single one of these services you've seen that are minus the ones that are external, there are GitHub repos, so like scattered around, and they're in different languages. And looking at this, I sat down with the team and said, okay, let's bring this over to our control again. Let's start by adding some ownership. So let's start by agreeing on a stack, the stack we agreed on for this. And I found that people found it quite interesting. I don't know why. We agreed on Node.js and TypeScript. It was because it was the common denominator of the team. And, you know, we need to learn banking first. So we picked a common language. And eventually, after we did that, we now want to start fixing the problem. So we want to attack the most critical problems first, which for us were the debit and boleto payments. And yeah, so that's how we started this journey. And yeah, I'm going to talk a little bit about the building side of this then. How did we found how the challenges we face and how we want to go about solving them. And well, I joined a bank, right? So thinking about a bank, I usually want the services to be reliable, even in the face of unforeseen problems such as network partitions or outages. We want code that we write to be as reliable as humanly possible. We also want it to be correct. Personally, I am, of course, interested in latency and throughput, of course, but if I have to build something that is slow but correct, I'll err in favor of correctness. And also, as I mentioned, Brazil's fintech market is highly competitive. So if we can build stuff that is correct and reliable as fast as possible and beat our competitors, that's a really cool thing to do as well. And yeah, imagine what we can do in order to hit all these pillars. When we looked at Temporal, we were like, yeah, this is probably something that can save us a lot of time and be a leverage for us. And then internally, we kind of like ask ourselves, okay, so Temporal is this great tool, but do we actually need to use it everywhere? And then we kind of like figured out that no, we actually don't need to use it everywhere. So we have like of course, this is not an extensive or like authority checklist, but this is something that we go through before writing a service. So for example, do I have external state that I need to keep in sync for my application? The answer is yes, then probably Temporal is a good fit. Do I need to coordinate between multiple microservices? Yeah, so if you do, maybe Temporal is a good fit for use case as well. And can I really need this to be durable, or can I get away with something like a cron job in Kubernetes that is simpler to reason about and spin up? Maybe if you can, then maybe reevaluate if Temporal is a good fit. But you'll see that for the two use cases I'm going to talk about, Temporal is the thing that actually helps us the most. So beginning with the debit transactions. This is a sequence diagram then of how the flow of a single debit transaction should work. You can see that we have a partner that actually sends a debit request and we send back a response. It has a maximum of 4 seconds. So we need to complete this transaction in 4 seconds, or we might need to undo some things, right? There's some validation that goes on. We need to adjust balance entries and actually charge the user for this transaction. There's some push notification that happens. And then eventually you can see here on the last step here is maybe we need to reverse this entry if something goes on. And usually this means that we just blew up the 4-second timer, right? We can't consider this a good transaction anymore. And eventually we reached out on the design of this. So we evaluated that there's external state when you can be sync. There's things we need to do with other microservices. So the design we got on this on Temporal was to have one workflow for the whole transaction, but we also have a child workflow that actually charges the user and sends a signal back to the parent workflow with the response code that we need to return to our credit card processor. The parent workflow has a global 4-second timer. So whenever that timer fires, we just basically reverse everything. And yeah, that was pretty much the design. And in terms of like a little bit of code, it's not the actual code, it's like to get an idea. The whole transaction is modeled as a single workflow from top to bottom. We have this, the first line is a cancellation scope using the TypeScript SDK. In there, we do some validations and start the child workflow that will do the account entry. And then when we receive the code, we just answer that back to the API that triggered this debit transaction. So pretty much it, not much to talk about here. It just works. And as for the account entry with rollback child workflow execution, we track any compensations that need to be done. So first of all, we add the account entry here, calling the external ledger, and then we append to the compensations array and try the signal. And if anything happens, we just run the compensations and reverse the money back to the user, right? And yeah, this actually solved a lot of problems, but before it did, we noticed that once we rolled out into production for the team to use, we found there was a high latency for the first workflow task to finish. And this was not scheduled to start. This was between the workflow task started and completed. And we're like oblivious to like, why does this happen? It shouldn't be happening. And funny thing, it was only the first one. The second one executed normally under normal time. And this was enough to break our use case, because if we have a 4-second timer on the transaction and we're waiting for 3 seconds for Temporal to start things, then we just can't use it. Eventually found out why. It was a stressful 3 days, but we realized that the key takeaway here is know your SDK. So Temporal TypeScript SDK does use a sandbox to run the workflow, and that does require some CPU cycles, and we had under-provisioned our CPU pod. And so being throttled all the time took a long time to advance the workflow, but once we figured that out after 3 days, everything worked out great. Everything worked fine. One thing that we also learned was that you need metrics, right? Because otherwise you can't compare it to what you had before. So basically we enabled the OLTP port in our Datadog agent, and that was it. Everything just worked. We also had tracing in the future so that we can see like the whole workflow activities and see all that. And basically with the new Datadog integration, that's probably going to be a little bit, once it hits the TypeScript SDK, right? These are some of the screenshot of our internal dashboards. These are the metrics that there's some business metrics, but these are the ones that we track for Temporal. And basically in the future, we probably want to use some of these to scale workers up and down. So yeah, in the future, once we need it, we might do it. We also look at the CPU and memory from Kubernetes. And yeah, so this year we have 4 pods for our 5 million or so customers. And yeah, it works fine. I can't really say that Temporal hasn't been like, apart from that one issue, it was super great. And yeah, so just to clarify here, this is 100% in production for all of our customers. And since then, we had 0 issues. Actually, we solved a lot of issues. Users no longer have like inconsistent bank account statements. People no longer have to reverse transactions manually. The workflows just take care of everything. And it's been great. It's been awesome. And yeah, so looking at that, and with that and under our belt as a success, we're like, okay, can we also do this for Boleto payments? Because Boleto payments today we actually lose money because we have some inconsistencies between the money that we pay to our external partner to pay the Boletos and the money that we charge the users. There's no distributed transaction, so that ends up in an inconsistent state, right? So again, this is the Boleto. This is how it looks like. We can pay this using our barcode scanner. And for this guy, we have a couple of challenges. The first one being the transaction line guarantee. So again, we want a saga for this. We want to be able to make the payment or not. And if we can't, we want to return the user to a good state where he doesn't lose money, basically. We also want to do some idempotency, so we don't want to make the same payment twice. It's really important. The third one it's very interesting because we also have a scheduling issue here. In any other application, any other bank, you can schedule this payment to happen in the future, a few days maybe, or even end of the month, for example, a couple of weeks, or even months, but I think that's less. That's more rare, but you could. And of course, we also want to make this asynchronous by default, as I mentioned. If we want to scale past 20 million users, we probably can be doing this synchronously. We don't have the resources to do that. And again, eventually you end up in the same spot. Like you build this like array of lambdas and SQS queues, and you end up with an architecture that looks like this. And you kind of ask yourself, like, can you do better? Can it be simpler? And the answer is yes, it can be simpler if you use the correct tools for the correct job. It can be very simple, actually. This is the entire architecture for the new Boleto payment. Basically, one thing that we solved was we don't no longer have like scattered GitHub repos. So we have a mono repo that contains the API component and the temporal workers component. And the API schedules payments and transactions through Temporal Cloud. And eventually we reach out to some external either external services or microservices to complete this transaction. And that is basically all we had. So we went from a convoluted architecture that could possibly be kind of like multiple queues and whatnot to this, which I feel like onboarding a new developer, even that he has to learn Temporal, is way simpler and way easier to reason about. And the mono repo setup actually makes all the code to be in a single repo. So again, you can commit something that fixes the API and everything without having to touch multiple repos. As far as where the code goes and how it's modeled, I really believe in transactions as a workflow. So basically here, the payment workflow receives the barcode and some other customer information as well as the value. We first do a check to see if this was already paid, because remember, if we're scheduling this, this code might be running in the future, so it might have been paid in that time frame. We append the charge for the customer, so we charge them for the boleto, and again, append the compensation. And then we pay the boleto like externally. So reach out to our external partner, pay it, and also add a compensation to reverse this if anything happens. And all of this surrounded by a try catch. And if there's an error, we just roll back everything. So that's pretty much the entire. Again, this is a simplification, but the idea is there. This is basically what we do. And I think that the icing on the cake on this. So again, this covers. It might look simple, but this covers the bad things that can happen. Make sure the user doesn't lose money. And if we were to do scheduling, that's basically sleeping before we follow along with the code, right? So you kind of like get scheduled for free in a asynchronous type of way. It's hard. Remember, if we're doing this without Temporal, again, queues and all that infrastructure work and all the harder time onboarding new developers and we just basically just get this for free if we're using the correct tools, right? And yeah, so we designed this, everything went great. The results are actually a work in progress. I'm sorry we weren't able to roll it out into production yet. It's a little bit more convoluted, but hopefully we'll get this by the end of the month, and maybe we can talk about this in Replay 2024. But yeah, for now, I wish I could show you like the results we have.